Hey, algebra. So here's our do now for today. For the point 12(7), which one is the x and which one is the y? You can hit pause while you work out your answers for that. Welcome back. All right, so the x always is that first number in the parentheses. It's going to be 12. Y is always the second one, so it's going to be 7. All right, so today we're going to continue our study of different forms of equations. We want to be able to recognize different forms. There's three of them, and we want to be able to change back and forth between those types of equation. So the three forms, just as a quick recap: slope-intercept form. This is the most common form, and usually if we're changing forms, this is the one where we want to end up. A couple of reasons for that. One, slope-intercept form contains the slope and the intercept, and those are very important uh, quantities for us to interpret into context, whether that's a story problem or real-world problem, some sort of data fitting. Those are going to be very important quantities for us to understand. The second reason is because this is the only form that can be written in function notation. And functions, well, it might not seem like it because we don't really understand the full meaning of it, but functions are a really big deal. And so it is important that this can be written in function notation. So the only difference between slope-intercept form with a y equals, like you see at the top here, and in function notation is literally the y has been replaced with f of x. And the way we write the equation doesn't change at all. So here's an example. We've seen this one before, but y equals -3/4 x plus 5, so that would be slope-intercept form. You got the slope there is -3/4, and you got your y-intercept of 5. Okay, the next form is standard form, and so that's ax plus by equals c. The a, the b, the c, those represent numbers. One of the kind of the rule for standard form is those are always going to be written as whole numbers, so you're not going to see fractions in standard form. But the easiest way to recognize it is that the x term, the y term, both are together on the one side of the equal sign with each other. So an example would be 2x minus 4y equals 12. And standard form is useful primarily for finding the intercepts, both the x-intercept and the y-intercept. And another fun fact about standard form, although we have not done this yet and we're not doing it right now, but standard form is useful if you have two rates combining to create some sort of total. Um, okay, our last form, point slope form, is y minus y1 equals m, and then parentheses x minus x1. Easiest way to recognize point slope form is that it has parentheses. It's the only form with parentheses. And in our example here, we have the point -4, +1 as coordinates of a location on the graph, and the slope -2. Okay, so we want to look at a couple of examples. So here's example number one. We're asked to write an equation in slope-intercept form for the line through the point 12(7), and which has a slope of 5/6. Okay, so the directions ask us for an equation in slope-intercept form. So we know we have to end in slope-intercept form, but that doesn't mean that we have to start from slope-intercept form. We have some options. Um, Standard form really is the only thing that wouldn't fit right here because we don't know anything about the x-intercept or the y-intercept, and those are the things we would need to write an equation in standard form. So that one we'll throw out from the get-go. But we are given the coordinates of a point, 12(7), and we're given the slope, 5/6. So it'd be a slam dunk to write an equation in point slope form. So that's an option. But we can also write an equation in slope-intercept form. We don't know the intercept at this point. We could do some work to find it, and we can use that to create our equation in slope-intercept form. So I want to look at both of those options. They both have a lot of value. Some of you may prefer one or prefer the other, but it's important for us to see them both. So let's look at point slope form first. We're given the coordinates of the point, 12 and 7. 12 is the x and 7 is the y, so we're going to bring both of those down into our point slope form where the x coordinate goes here, follow the green arrow, the y coordinate goes over here, follow the blue arrow, and then our slope of 5/6 we're going to pull down and put into the slope spot, follow the red arrow there. Um, okay, so that's going to give us y minus 7 equals 5/6, and then parentheses x minus 12. The end, point slope form, done. However, since the directions ask for our final answer to be in slope-intercept form, we would need to take this equation and change it over to put it in y equals mx plus b form or slope-intercept form. So that's going to take two steps. The first step is we're going to distribute the slope into both terms inside those parentheses. So I'm going to take the 5/6, multiply it onto the x, also multiply it onto that negative 12. That's going to give me my next step. Second step, I need to get the y by itself. In order to do that, we'll do the opposite operation to get rid of that -7. So I'm going to add 7 to both sides of the equal sign, and that's going to bring me to my final answer, y equals 5/6 x minus 3. Okay, I do want to look at the same exact problem from a different perspective. What if we want to use slope-intercept form, not just as our final answer, but stay in slope-intercept form from start to finish, all of our work in slope-intercept form? Okay, we can do that. So we don't know what the y-intercept is, which means we can't just write our final answer. But what we can do is use an algebra trick where we solve for an unknown. So we have the slope, 5/6. We know that 5/6 is going to go into the m spot, so follow the red arrow there. And we are given an x value and a y value that we know the line goes through, that point, 12/7. We can take the 12 and use it to replace the x in our equation, and we can take that 7 and use it to replace the y in our equation. So that's going to give me 7 equals 5/6 times 12 plus b. And that b is my unknown. So I've created basically a one-step algebra equation that we need to solve for b so we can find out the y-intercept and write our final answer. So I'm going to multiply inside the yellow highlighter here, 5/6 multiplied by 12. That's going to give me 10. And then to solve for b, subtract 10 on both sides to get a final answer of -3. That -3 is going to go back into the b spot of my mx plus b. So my final answer, 5/6x minus 3. The exact same thing we got at our first attempt when we started from point to slope form. All right, let's take a look at a second example. This time we're asked to write an equation in slope-intercept form for a line passing through these 2 points, 1, 5, and 2, -3. Okay, so again, let's take stock of what we got. We know we need to end up in slope-intercept form, and so we're going to have some options here. We could work in slope-intercept form from start to finish. We could maybe start in a different form and then change over to slope-intercept form. So let's consider some options. Standard form, again, is the only one we can throw out right away. We don't know anything about either of the x-intercept nor the y-intercept, so that one's out. But we could do either slope-intercept or point slope form, just like in the previous example. The catch here is that we don't actually have any information to start either of them. We have 2 points, so it kind of gives a little bit of a head start to point slope form because we do have a point. But we're going to have to do some work no matter which of those options we want to pursue. So whichever option we choose, our first step has to be to get the slope because we need slope whether we're doing slope intercept or point slope. That's the one common element. So let's take a look at how to find slope. You could plot these 2 points on a piece of graph paper and then count squares on your graph paper to find your rise and your run, put them together to create your slope fraction. We'll give you the exact same answer that I've gotten here, but you'd have to have graph paper. The other option is to use the slope formula, which says m, slope, is y2 minus y1 on the top, divided by x2 minus x1, and that's where we get our slope fraction. So there's a lot of numbers to keep track of, and a lot of times students get confused about which number goes where. So I've done some color coding. I've circled both points in different colors. So the green represents 1.15. Those two numbers go together to create 1 point on the graph. And then inside the blue circle, 2, -3, those two numbers go together to create a single point on the graph. And in order to find slope, we need to know which one is the x and which one is the y coordinate for each of those 2 points. So I've color coded them, the x coordinates magenta, the y coordinates both in yellow. So to find my slope, my first step is to subtract the y coordinates. Those go on the top of my fraction. And so those are going to be the yellow points, 5 minus -3, and 5 minus -3 is subtracting a negative number. That's a double negative. So I could just rewrite that as a plus 5 plus 3. It's going to give me the 8 that you see over there on the top of my slope fraction. On the bottom of my slope fraction, I'm going to subtract those two magenta numbers, and I need to go in the same order that I did on the top. So I did green minus blue. So on the bottom, also green minus blue, but this time with the magenta coordinates. So 1 minus 2. Okay, on the bottom, 1 minus 2 is going to give me -1. So my slope fraction is going to be 8 over -1. When I divide that, I get my final answer of -8. So there's my slope. Once I have the slope, now I need to decide, am I going to go ahead with point slope form or slope intercept form? Let's take a look at both, but one at a time. So I want to see the point slope option first. So I'm going to use the slope of -8, but to create an equation in point slope form, I only need one point. So choose either the green point or the blue point. If I was to choose the green point, since it happens in the equation, in the story first, then my equation will look like this. So I'm going to use the 0.15, that slope of -8 that we just found. I'm going to put the x coordinate over here in the parentheses where the x goes. The y coordinate 5 goes over here with the y, the slope of -8. So I get this green equation. That is my equation in point slope form. Now, what if I'd chosen the blue point? If I'd chosen the blue point of 2, -3, I'm going to get a different looking equation in point slope form. I'm going to get y plus 3 equals -8, and in the parentheses, x minus 2. So my x coordinate of +2 goes here, and in the equation, our coordinates always have the opposite appearance. So it's going to say x minus 2, even though the coordinate had a +2. And the y coordinate of -3 is going to come into the equation really as y minus -3, but I've gone ahead to change that to positive because subtracting negative is the same as adding. So I have a green equation up here, I have a blue equation down here. Both of them are in point slope form. They do both look different because that's the way point slope form works. It's both an advantage and a disadvantage. You can use any point you want. You're not tied into just this one special point, and it has to be that one and nothing else will work. You got options. But the disadvantage is kind of confusing because you get all these different looking equations and you're like, it doesn't look like the same equation. It's got different numbers in it. And it actually represents the same line. It's like putting it in one costume versus putting it in a different costume. Really, it's the same line, but sometimes it's hard to recognize it because it's in a different costume with the different coordinates of those different points. Okay, we'll get my final answer. I got one more step. I need to convert point slope form into slope intercept form. It's going to take me 2 algebra steps. I'm going to work from this blue point slope equation. My 2 steps are going to be to distribute the slope and multiply that -8 through the parentheses. And then my second step is to get the y by itself using the opposite operation. So I subtracted 3 on both sides of the equal signs. Final answer, y equals -8x plus 13. All right, well, let's take a look at that same process of getting an equation, but this time using only slope-intercept form. So I still need the slope of -8. And this time I'm going to pick one of those 2 points. And again, you could choose either the green one or the blue one. I chose the green because it was written down first. So I'm going to use 1, 5. I'm going to take the 1 as a replacement for the x in y equals mx plus b. And the 5, which is the y coordinate, I'm going to use to replace the y in y equals mx plus b. The slope of -8 replaces m, and then b is my unknown. I do not know the y-intercept at this point, so that's going to stay as a variable, the letter b, and I'm going to solve this algebra equation to find out what b is. So I had to multiply -8 times 1, which gives me -8, and then in order to get the b by itself, I did the opposite operation. I added 8, found out that b would be 13, which then I can plug back in along with the slope to get my final answer, y equals -8x plus 13, which, you remember, was exactly the same thing we got when we started out using point slope form.